Hi everyone! Today we're focused on Module 6, Lesson 10, and our topic is linear models. So our objectives today are going to be that students identify situations where it is reasonable to use a linear function to model the relationship between two values. And that's our best fit line that we're talking about. It's a linear model. Our second objective says students interpret slope and the initial value in a data context. So we're going to end up interpreting the rate and also kind of where our data starts, which is going to be represented by our y-intercept. So the example that we kind of want to think about is like how many hours of sleep I get during the night. And in this case, I'm going to have a dependent variable and an independent variable. Now, the difference between the dependent and the independent is that the dependent variable is my y variable, and this is the variable that is going to be predicted by my independent variable, which is my x. Independent is the predictor. So it's almost like saying, how much snow are we going to get? The independent variable might be the temperature outside, while the dependent variable is the amount of snow, because the temperature is going to affect how much snow we have. So when we think about mathematical scenarios that have relationships, we are kind of thinking about two pieces. We're thinking about the response and the explanation. So the response is that dependent variable, and the explanation is that independent variable. So the response is affected by the explanation. So a couple examples of responses would be like the height of a sun, the number of burgers to make, the time it takes to run a mile, and how many bees are in a hive. And some potential explanations for those variables. When I'm talking about the height of a sun, you're probably going to look at the height of the mother and the father. With the number of burgers to make, you're either looking at the number of people or maybe the cost of how many hamburgers there are. The time it takes to run a mile might have to do with the elevation of the location you're running in, but also the amount of practice that you put in beforehand. And the number of bees in the hive has to do with the size of the queen bee or the amount of honey that needs to be harvested. So we always want to think about kind of cause and effect being our dependent and independent variable. The next example we're looking at is just a simple geometry application. If I had a piece of wood that I needed to get cut in two sections, there's a fixed cost of going to the contractor and having them slice into that material for me of $2.25. And then each additional cut is going to be 25 cents. Another thing we need to know is that the first cut is free. So thinking about my variables and what I've been given, I have $2.25 as a constant cost and 25 cents as the cost per cut. But I also need to take away that first cut, which is an additional 25 cents. So when I simplify that expression, I'm getting y equals 0.25x plus 2, which is y equals mx plus b, so my slope would be 25 cents per cut, and my intercept would be 2. So if you need 3 cuts, you're going to get 25 cents times 3 cuts plus 2. In Module 6, Lesson 11, we're going to be using those linear models to interpret our data and to kind of make predictions on our data. So the first objective is that students recognize and justify that a linear model can be used. So if I have data that is clustered very heavily, I'm probably not going to use a linear model. And my second objective says students interpret the slope of a linear model to answer questions. So I just want to think about looking at the data in any particular relationship. I want to be able to identify really quickly whether there is a positive trend or a negative trend in my data. And one way to do that without a graph is to look at the variables. So do both variables increase over the course of the data set? Or does one variable increase while the other is decreasing? So those are kind of the factors that I would look at in terms of a data table to establish positive or negative correlation.